Okay, so this is solving for sides, which we're not going to do right now. Oh, so cool. Since I'm using my backup camera, I can move this down and it doesn't screw with my camera anymore. Ha! I'm winning. Okay. So let's see. Let's look at solving for angles. Nathan, how's it going? Welcome in. Okay, so solving for angles. I still have some solve for side examples up here for anybody if they're confused at any point. There is actually a raise hand button that you can hit um, that will flash up a signal. So if you have a question, I'll be able to see immediately that you have a question and I can stop my tirade and answer your question. I think I'm getting better at this. Okay. So in these problems up here and the problems we've done so far, we're always looking for a side, right? And we're going to use SOHCAHTOA, bum 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 bum. We're going to use SOHCAHTOA to find it. Finding an angle is basically the exact same thing. The only new thing I'm going to have to teach you is a new button on your calculator. That's basically it, okay? So here's a phrase that you're going to hear me say a million times over the next couple of videos. What do we have? What do we need? Well, in this case, what we have and what we need are a little bit different because what we need is the angle. But we have two things. Which two sides from this angle, and I'll talk about what that actual symbol is in a second. Which two sides from that angle do we have? It's a rhetorical question. You don't have to answer, but you can if you want. Participation would be awesome. Well, we've got this side over here. And I'm going to call that the opposite side. And we have this side here, which I'm going to call the adjacent side. We've got the opposite, we've got the adjacent. We need to find the angle. But the setup is exactly the same. Like we're still gonna write SOHCAHTOA. And we're still gonna figure out which of these ratios do we need to use. And I'm just gonna sit for a second, let you think about it. There's only one of those that has both the opposite and the adjacent, and that's tangent. But we don't know what tangent is. We've got this weird symbol here. What the hell is this even? We ran out of regular letters at some point, we mathematicians, so we started using Greek letters. That is a theta. It's a Greek letter. I think it makes a TH sound, but I don't know for sure. I don't speak Greek. Theta is kind of like X in that it's the default letter that we use for angles pretty much from here forward. So just like if you see a distance that you need to find, your first thought is, oh, let's make it X. With angles, it's the same thing except it's theta. Theta is kind of the most common there. So we need to find theta, which is basically X. You can put in X if that makes you more comfortable. I don't care. Okay, so we're still using tangent. So we get tangent of theta degrees. We don't know what theta is. But we know that it's equal to opposite over adjacent. Opposite is 13.9. Adjacent is 11. Any questions on the setup so far? Because this is where the new stuff starts, and I want to make sure everyone's good with the setup here. Has anything that I just said or anything that we just did confused anyone in any way? Can I answer any questions? So we're going to, we just made up sine, cosine, and tangent. Can we all agree on that? Like, some math is made up and some math is kind of discovered. Sine, cosine, and tangent, the names, sine, cosine, and tangent, we just made those up, right? So that is a process. When you have tangent of an angle, you put in an angle and you get out a ratio. Angle goes in, ratio comes out. So what we need is an inverse, a way to undo tangent, a way to start with a ratio and get an angle. Now, those of you who are in the room right now, please have a calculator in front of you. I don't care what kind of calculator. It can be on Google, it can be an actual calculator. Have a calculator in front of you, please. Because I'm going to show you a new button on that calculator that will show you how to undo this. So there are two ways to write this undo tangent function, okay? We just made up the word tangent. We're going to make up an untangent so that we can get that angle out of there, right? We can't divide by tangent. Tangent isn't a number. And on your calculator, it should look like tangent -1. And you can find it by hitting the second or shift button. Here's my calculator. There it is. And you can see the sine, cosine, and tangent buttons. And if you look really close at the sine, cosine, and tangent buttons, if it focuses, you can see that sine -1, cosine -1, and tangent -1 above that. It is called inverse tangent, or I prefer calling it arctangent. Not just because it sounds way cooler, but because this -1 looks an awful lot like an exponent to me, and it's not. It's there to indicate undo tangent, and I don't like using an exponent that way. I feel like it's confusing. So I usually use arctangent, but you're going to see the other one because that's what everyone else uses. So for the problem, we're going to untangent both sides. We're going to arctangent both sides. And we're going to get theta equals the arctangent of 13.9 over 11. So on my calculator, I should charge my battery on this. On my calculator, I'm going to hit the second button. Here, in fact, there we go. On my calculator, I'm going to hit the second button and then the tangent button, and it should give me that tangent -1 of 13.9 divided by 11. So this is what it would look like on my calculator. A Google calculator would work much the same. iPhones are all kind of crazy. You have to do all sorts of weird backwards nonsense. I'm not a fan myself. Going back to screen sharing, if I can. There we go. So I got 51.64 degrees. And I'll sort of separate this off from everything else. Okay, so the thing that we're doing, the only really new thing here is this arctangent. And since tangent itself is already really new, you know, it's not that, it should not be that big of a leap. If we invent multiplication, we also have to invent division. We have to invent some way to undo the thing that we just did, at least in math. In engineering, nothing is reversible. Any questions on that example? So the steps really are to identify, if you're looking for an angle, identify which two sides you have. And by the way, while we're talking about this, we could have figured out this side if we wanted to, yeah? If we wanted that AB side, we could have used the Pythagorean theorem to find that, and then we could have used sine, cosine, or tangent. Any one of them would have worked. So you have options. This one was just the most straightforward method for this particular problem. Let's take a look at number 2. Okay, we've got our theta here in this small acute angle. And we've got a 14 and a 15. Well, this 15 is the hypotenuse. You should always be able to recognize the hypotenuse as being across from the 90-degree angle. And then this apparently longer leg is the leg that is attached to theta, right? It's part of the angle. So that is the adjacent leg. I'm not quite geeky enough to get SOHCAHTOA like tattooed onto me. Having the pi tattoo is as far as I'll go, but it would not be a bad idea to write SOHCAHTOA in pen on like the back of your arm or something and just look down at it every now and again, because we're going to be using it a lot. SOHCAHTOA. Hopefully while I was jabbering there, you figured out that the one that we're using is the one with adjacent and hypotenuse, which is cosine. But again, it has to be cosine of some angle, and we don't know what that angle is. It's cosine of theta degrees equals adjacent over hypotenuse. Adjacent is 14, hypotenuse is 15. So then I arc cosine both sides. And we're back to the calculator. Now, really quick, if you've got your calculator in front of you, because this is a thing that happens sometimes, go ahead and do that second cosine -1. It should look like that. Do that cosine -1. And instead of 14 over 15, do 15 divided by 14 and see what happens. And I want you to see it, because if you see it later on when you do it, or if you see it later on in your homework, I want you to understand why. Okay, so I really want you to actually grab your calculator and do cosine -1, which is the same thing as arc cosine, remember, two different words for the same thing, of instead of 14 over 15, do 15 divided by 14. We know that cosine is adjacent over hypotenuse. We also know that the hypotenuse is always the longest side of the right triangle. So if the hypotenuse is always on the bottom, that fraction always has to be less than 1. Does that make sense? I hope. If the hypotenuse is on the bottom, then the whole fraction has to be less than 1. The only way you get a number bigger than 1 is to put a bigger number on top and a smaller number on the bottom. So if you accidentally flip your fraction and get a number that's bigger than 1, 15 over 14 is 1 point something, then your calculator or computer or whatever will let you know that you're trying to cosine something that you can't cosine, or arc cosine. You can't arc cosine anything bigger than 1 because there is no angle that will give you a ratio of bigger than 1. The hypotenuse has to be on the bottom. It's always less than 1. That was a long-winded way of putting that, and I think I will keep that out of the video, but I hope it made sense. Let's look at another one. So don't do 15 over 14. Oh, actually, let me do the arc cosine here. Second, cosine -1, 14 divided by 15, enter. I got 21 approximately degrees. I got 21.03 degrees, about 21 degrees. And I know I say don't trust the diagrams, but at least kind of glance at the diagram. Does that look like a 21-degree angle? Yeah, I mean, it probably isn't. You know that when I make my diagrams, I certainly don't care if they're the actually right angle, correct angle. But it looks about right. If it had said 97 degrees, I would have been a little suspicious. Let's look at another one of these. This one right here. Here's our theta. We got a 5 out here and a 6 right here. I am going to step away for a moment because if I don't, I will feel the need to help out right away. I want to really give the folks who are here and working a chance to give this a shot without me coaching you through it. So I'm going to turn my mic off and I'm going to go get a drink of water and I will be right back. Let's see. So it looks to me like we have the opposite and the adjacent legs. And we don't really care about the hypotenuse. I mean, we could figure it out, but we don't really care about it. And we need the angle theta. So again, and I can't stress this enough, the setup is exactly the same in these solving for angle problems as it was in the solving for sides problems. The only difference is where the variable is. Okay? We have opposite and adjacent. I am once again going to write down SOHCAHTOA. Like a crazed prison inmate, I'm just going to write it over and over and over again, scribbling it on my whiteboard. And so which one? Eeny, meeny, miny, mo. Tangent's the only one that has opposite and adjacent. I know I keep saying this, but if we use the Pythagorean theorem to solve for sad face here, then we could use sine or cosine or tangent. Any of the three would work if we knew what that hypotenuse was. And we could find out what that hypotenuse was, but why do 2 steps when, we can do it in 1? We know that tangent of whatever theta is equal to opposite over adjacent, 5/6. Now, tangent is totally allowed to be bigger than 1 because tangent is opposite over adjacent, and there's no rules as to what proportions the opposite and adjacent side have to have. Tangent can be anything, okay? Anything positive. So tangent theta equals 5/6, and hopefully it makes sense that just like there is a sine inverse and a cosine inverse, we get theta equals arc tangent of 5/6. Which again, on the calculator, it really wants me to charge this battery. Arctangent 5 divided by 6, I got 39.8 degrees. Any questions on that? Is this making sense? Do you see how powerful this can be? Like now, we know that if we've got two sides of a right triangle, we can also find everything else, the other side, the two angles. And if right triangles were like, who cares about right triangles, then this would be who cares, you know? But right triangles are all over the place. I mean, I have right triangles and right angles all over my apartment right now. We humans love ourselves some right angles, and therefore we love ourselves some right triangles. So basically anything that you go into, from art to architecture, you know, anything that requires you to do any sort of visualization whatsoever is really going to be heavily reliant on this sort of trigonometry in one way or another. Okay. Last example. Then I will go back and I will do some solving for sides examples as well, just to make sure everybody is on the same page. Plus, we've only been at this for 40 minutes, so, you know, we've got plenty of time. Okay. So my theta is here. And I once again have opposite and adjacent legs. I'm not going to go through my whole SOHCAHTOA rigmarole again. I'm just going to say that tangent of theta equals 9/8. Oscar, welcome. Glad you're here. So tangent, opposite over adjacent. So tangent of this theta, since Oscar just got in, I will remind everybody that that symbol, it's like an oval with a slash through it. That symbol is the Greek letter theta. You will see it a lot when it comes to angle measures. And then on the calculator, we use that horrible tangent -1 button of 9/8. Tangent -1. Nine divided by 8. I don't know if you can see that because I'm not full screen for you, but I got 48.37 degrees.